Most of these are exponent problems, and only 2 of them are exponentials. Exponent problems are different than exponentials. In an exponential, you have an x in the exponent. I'm going to say that one more time. Exponentials have an x in the exponent. Just a blank on the back, so I'm looking for it. Okay, good. All right, so my question is on that first one, do you know the exponent problem? Well, it's either a to the 5th or it's a to the 6th. And I hope you know it's a to the 6th. But if you had to prove it to somebody, and it's just not like, well, here, I type it in the calculator and it says x to the 6th, or a to the 6th. How do you prove it to somebody? I think this is a good way to prove it. A squared is like a times a to the 3rd. How are you going to make a times a to the 3rd come out to a to the 5th? There's no way that would be a to the 5th. Do you get how it would be a to the 6th, though? So if you have trouble with one of these, let's have you shut the door over there, please. Thank you. Carlos has got it. All right. So I think if you look at this, you might get confused on what the answer would be. But I think if you write out a times a over a times a times a, here's a few things about canceling you might not remember. When you cancel these, do you remember that you're technically leaving a 1 behind? You're technically reducing that to 1 over 1. If you didn't know that, you need to know it now. Because when you cancel all the stuff on the top, some kids think it's just all gone. And it's not. It's really 1 times 1 on the top, which is leaving a 1 on the top. So, of course, the answer ends up being 1 over a. Now, a lot of people are uncomfortable with that. They just want to write it as a to the something. If you had to give that a number, it would be a to the negative 1, which kind of makes sense because 2 minus 3 gives you negative 1. Do you get that? It's a to the negative 1, which is the same as 1 over a. And in the battle between those two, you're not allowed to leave negative exponents. Ever. Don't ever give the answer to a problem with a negative exponent in it. It's like a faux pas, like ending a sentence without any punctuation. Teacher would, you can expect in an essay, they're going to mark that wrong. Just like a math teacher, if you leave this, we're going to mark it wrong. You instead have to write this. So to a negative power means 1 over whatever you had. So let's make sure you really get that. So what's 25 to the negative 1? Take a second, write down what you think the answer is. And please compare it to the kid next to you. You know who I always pair you with. Eats 2 rows straight across, forward and backwards, forward and backwards. Just a quick check. Compare that answer, that one answer. All right, you either get this at this point or you don't. It's 1 over 25. Who got that? Raise your hand if you got that. Okay, cool. Here's a weirder one, though. 2/3 to the negative 1. What does that mean? You have a guess, don't you? Take your guess. Compare with the kid next to you. See what you think it comes out to. That is a good guess. 3 over 2 was correct. It just flips it over. So negative 1 in a power is like you flip it over. And you might be like, well, that's different than the last one because that didn't flip over. Well, kid did kind of flip over. Because if I put this over 1, see, you can always put something over 1 if you want. Then it just flipped over. Okay. How about the old anything to a power of 0? Do you know what that's equal to? 1. Anything to the power of 0 is 1. All right. Now, we're going to go back to, on this list of a whole bunch of things, a lot of them are exponents. Exponentials have x in the exponent. And this is an exponential. And this is an exponential because it's a graph of something with an x in the exponent. Okay, this is the new function. Like you've learned a whole bunch of functions. There's actually 12 that you learn in pre-calc. You already probably know 6 out of the 12. Like if I said y equals x squared, you guys know what that looks like, right? And the absolute value function is like a V shape. Remember that one? Okay, here's a new one for you. It's the exponential function. It's like y equals 2 to the x. And 3 to the x would look just like it, except a little steeper. And 4 to the x, a little steeper. 10 to the x, very, very steep. 10 to the x would be like, whoop, almost straight up. All right. So that's your new function. It's called an exponential function. So we have to, in math, always remember what we just learned and tie it in to the new stuff that you're learning. So let me give you one of the ones you just learned. un equals un minus 1. And then I could add, but these kind aren't like the add kind. This is like the times kind, like 1 plus 0.3. Would you agree that that 5 is going to have 30% growth? Okay. Now, is this an exponential? No, it does not have an x in the exponent. But I could make it into an exponential. All right, so far, you haven't written down too much. I want you to copy this exactly, and then underneath it, I want you to change it into an exponential. This is a typical math problem. We say, take this function, which is not exponential. It was called a recursive sequence, and make it exponential. Well, then you know there's got to be an x in the exponent, right? Here it is. Y equals, starts with 5, multiplies by 1 plus 0.3, x in the exponent. There it is. That is an exponential. It'll do the same basic thing. You want the third term, you put in x equals 3. That would mean you'd times by this 3 times, which is kind of what you do when you want to find the third term. Okay. All right. Now, if I had just started with this and hadn't connected it to any of the old material, I would have said, put your starting amount here. Always put 1 plus, if it's growth. Do you get, if it's decay and going down every time, you'd put a minus right there? Okay, and then this was the rate. You knew that was 30%, didn't you? And then you always put an x in the exponent. And that's usually time. In real world problems, it's been like 3 years. And so you put a 3 there, and then that'll get you your answer. If you're putting this in a calculator, would you agree that that's going to be like a caret to the power of? If you forgot that, that's a reminder. Put to the power of 3. All right. Let's make sure you remember that. Just use your iPad. You don't need the old calculators for this one. In fact, you won't be able to use a calculator on this test. At least, well, actually, I could be wrong on that. But at least today's stuff, there's no calculators. So just use your iPad's calculator to do this. What I mean is, you're not going to be using graphing calculators for this. You're going to be using a calculator. So do you know how to type this in? That's kind of what I'm asking. You're going to put in a 3 for the power. You can use just your iPad's calculator. It's fine. So you go 5, parenthesis, 1 plus 0.3. You just type it in exactly as you see it, except power of 3. When you get that decimal, would you please compare it to the kid next to you? Take a second, type it in. Looks like it's 10.985. Can you guys verify that? Okay, cool. All right. So, we're almost ready for your homework. Seriously, this is it. If you've been really listening close, you've got this. I'll show you an example problem. Minnesota had around 4,000 moose at one point, and the sad thing was that they were declining by like 5% per year. I'm telling you a true story, basically. I'm making up exactly where there are 4,000 moose, of course not. Was it exactly 5%? Of course not. But it was going down. The population of moose in Minnesota was going down. It was kind of sad. It turned out that they were getting sick, and then the wolves would eat them, and then people were like, it's the wolves. The wolves are killing all the moose. But actually, the moose can handle a wolf pack unless they're sick. A moose is tough. And those things can kick so hard, it can kill a wolf with every kick. I'm not saying it does, but it could. So they're tough. But if they're really weak and worn down, and then they're in deep snow, and yeah. So anyway, there is your story, and there is your exponential problem. And I'll tell you how they get more complicated, but first let's make sure you get how to write these. You see I started with 4,000 moose? See I had it going down 5% per year? All right. What if I asked you, how many moose will there be in 10 years? Well, you just put a 10 here. That'd be it. Don't do it. I'll save time. You get what you do, right? Just type that into the calculator, and that's it. These are so much easier than that last unit. But that last unit, called recursive functions, is in both the state's standards and on the ACT, which is supposed to be a judge of how prepared are you for college. So most colleges would expect you to know recursive sequence, so we needed to teach you that stuff. But I'll give you, these can do the same basic thing, and they're way easier. Okay, so I'm going to give you a situation now. You're going to be an alpaca farmer. So now your alpaca flock, you start with 12 of them, and write this equation, please. Write this equation. You got 12 to start with. You already know the beginning of your equation. And now, if you farm them well, and you feed them, and you take good care of them, and play alpaca-friendly music at night to keep them happy, you get 45% growth every year. All right. Please, make an exponential equation. Show it to the kid next to you. See if you got the same thing. All right. Cool. What if you were a really bad alpaca farmer? You basically don't feed them well. You keep them up at night. You allow nasty predators to eat to them occasionally. Then it's going to be like negative 0.45. And that means your flock would shrink 45% every year. All right. Now, if I asked for 3 years later, you just put a 3 here. But I'm going to do something different than that. I'm going to say, yes, it shrinks 45%, but it only shrinks 45% every 18 months. So that's going to change things, and there's a really easy way to handle it. Divided by 18. See, if it only grows or shrinks at 45% every 18 months, then if 18 is put in the equation, you got effectively a power of 1 then, right? And then you're going to do this once, which is 1 multiplication by 1 minus 0.45. All right, so I want to make sure you get the difference here. If I said, here's my equation, how many do I have after 18 years? I'd put an 18 right here, and I would multiply this all out with a little caret 18, okay? But if I had said, our data is kind of weird on this one. We only know that they will decrease 45% every 6 months. Every 6 months they decrease 45%, then you divide by 6. You get the difference there? As opposed to, it decreases 45% every year, and I want to go 10 years, I just put a 10 in here. But if the decrease 45% isn't every year, it's like every 3 days, you divide this by 3. All right. Most of the ones for today, they're really simple. You're just going to stick the number right there. I'm just trying to get you ready for the more complicated ones that are coming later. All right. So, that's it. You can now do this. It's a worksheet. It's easy. You just skip the last problem on the worksheet. Open it up. Now, what if you want to check and make sure you're doing it right? Well, do the first problem. Go look at the answer key. Remember how this is supposed to work. if you look at the answer key and yours is wrong, or you didn't have the answer and you had to copy it from the answer key, you should bring that in red or some other color that's different than what you're going to do your homework in. Your homework should be one color. Your grading should be in a different color. So if it was right, you leave it alone. Don't have to put any new color in there. But if there's something, you look at the key and you're getting your answer from the key, you should be doing that in a different color to show me, yeah, I had to get help a lot on this. Remember, you'll still get a 5 out of 5 as long as you do all the problems, show all the work. But I just want to see which ones are coming from the key and which ones are actually from your head. Because a kid who has them all right without the key, yeah, it's totally different than a kid who still gets 5 out of 5, but got them all from the key. I just want you to be honest with yourself about that. All right, so on that very first one, Jack Breen, I am guessing you're already done. What was 1A? And don't read me the problem. Just tell me what you thought the equation was.
Like the answer?
Yep.
Y equals 2,500 in parentheses 1.06 to that.
I'm just going to put plus 0.06. It is the same as 1.06 to the x. All right, good. That's all there is to it. And again, I don't think there is even any problems where you're going to divide by like 5 here or whatever, but that's coming, and I want to just pre-teach it to you so that when you hear it grows 6%, but only every 5 days, you'd know, oh, divide by 5 then. That's for a more complicated future assignment. All right. And now, if you get stuck, there's a key. You can go look at it. Just got to mark that accordingly. That's all I have for you for today.